this video, we're going to discuss gas law. So, there are many types of gas law, which is Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, Dalton's law of partial pressure, combined gas law, ideal gas law, and gas density. So, these are the pressure units. In 1 atm, there is 1.01325 kilopascal. In 1 atm equals 10135 pascal. In 1 atm equals 760 millimeters mercury equals 760 torr equals 1.01325 bar equals 29.92 inches mercury equals 33.91 feet war and equals 14.7 psi or pressure per unit area. Okay, let's begin in gas STP. So gas is STP, standard temperature and pressure. Constant units, which is temperature is 273.15 Kelvin, pressure equals to 1 atm, volume is 22.4 liters. So there's a Boyle's law problems. Formula P1B1 equals to P2B2 at a constant temperature. So there is a problem in number 1. If 400 cubic centimeter of oxygen are collected at a pressure of 9.80 kilopascal, what volume of the gas occupied in the pressure is changed to 9.40 kilopascal? So we need to solve that. We need to find the volume, the final volume. So let's begin. We have volume 1. Volume 1 equals 400 cubic centimeter, and pressure 1, volume 2 is unknown, so that's we need to solve. And pressure 1 is equals to 9.80 kilopascal, and the pressure 2, which is 9.40 kilopascal, right? Kilopascal. So that's it. So the formula is P1B1 equals P2B2. So let's begin. Solution. These are the givens, right? And this is a solution. So P1B1 is equals to P2B2. Okay? And we need to find the B2 because we need to solve this. So divide both sides by P2 in order to get the value of B2. So cancel out P2, and the left is B2. So equals B2 equals to P1 B1 over P2. Okay? Did you get it? So we need to plug in those values. B2 is equals to pressure 1 equals 9.80 kilopascal. 9.80 kilopascal times the volume 1, which is 400 cubic centimeter, 400 cubic centimeter, and over the pressure 2. The pressure 2 is 9.40 kilopascal. 9.40 kilopascal. So you need to cancel out this kilopascal, and the left is cubic centimeters. So volume 2 is equals to, so 9.80 times 400 divided by 9.40. So equals 417.02. 417.02 cubic centimeter. Okay, that is your final answer. Okay, right? Did you get it? And how about in number 2? Calculate the pressure of gas which occupies a volume of 100 cubic centimeter if at a pressure of 95 kilopascal. It occupies a volume of 200 cubic centimeter. So we need to solve the pressure 1, the initial pressure. So the given is volume 1 equals to 200. Where's volume 1 here? 200 cubic centimeter. Okay. No, it's a volume 2, sorry. Volume 2 is 200 cubic centimeter, and a volume 1 which is 100 cubic centimeter. So volume 1 equals 100 cubic centimeter. And pressure 1 is unknown. We need to solve the pressure, the initial pressure. And pressure 2, which is 95 kilopascal. Again, these are the givens. Given. And we need to solve that. Solution. Use again the formula. P1 B1 equals to P2 B2. Okay. And you need to find the pressure 1. So divide both sides by volume 1 over volume 1. Then cancel out volume 1. So pressure 1 is equals to pressure 2 times volume 2 divided by volume 1. Okay. So pressure 1 is equals to the pressure 2, which is 95 kilopascal. So 95 kilopascal times the volume 2. The volume 2 is 200 cubic centimeters. 200 cubic centimeters. Then how about the volume 1? The volume 1, which is 100 cubic centimeters. Right? 100 cubic centimeters. So cancel out both cubic centimeters. On the left is kilopascal. So pressure 1 is equals to 95 times 200 divided by 100 equals to 190 kilopascal. So that's your final answer. Alright? This is the problems of Boyle's law. So we need to continue in Charles' law. So please like and subscribe.